In this video, we're going to look at another example of an improper integral, that is, how to determine if the improper integral converges or diverges. So we're going to look at the integral from 0 to 1 of natural log of x. So first let's see why. So we want to see if this integral converges or diverges. We first want to see why this is an improper integral. The function f of x equals natural log of x is undefined at 0, which is, you can see the lower bound of integration here. And also, as x approaches 0 from the right side, the function natural log of x becomes unbounded. And that's, again, the reason why this is an improper integral. Let's sketch the graph and see what this integral represents. So we should be familiar with the graph of natural log of x. So here's the graph of natural log of x. And you can see at 1, natural log of x is 0. And the integral represents the area between 0 and 1, as you can see below the x-axis. This is the region enclosed by the x-axis, the y-axis, and the natural log function. Since the region is below the x-axis, our expectation is that if the integral converges, the answer should be negative. It should be a negative finite number. And if the integral diverges, we should expect the answer to be negative infinity, one of those two. So if you get a positive number as your answer or positive infinity, it definitely means you did something wrong and you need to go back and retrace your steps. So knowing that, we can now start to evaluate this improper integral. First, we're going to define it as a limit of proper integrals. So again, here's how you do that. You sketch or represent here the interval from 0 to 1. You let t be any positive number less than 1 and greater than 0. And the integral from t to 1 is proper. And as t approaches 0 from the right, the answer, the limit, will be equal to the improper integral from 0 to 1 of natural log of x. So the integral from 0 to 1 natural log of x dx is defined as the limit t approaches 0 from the right of integrals from t to 1 of natural log of x dx. We need to find antiderivative of natural log of x. We do that using integration by parts, with u equaling natural log of x and dv 1 dx. So du is 1 over x dx, and v is equal to x. So the integral of antiderivative of natural log of x is equal to u times v, which is x natural log of x, minus the integral of v du, which is x times 1 over x dx. So you can see the integral on the right is much easier. This is x ln x minus the integral of 1 dx, or x ln x minus x. And now let's return to our evaluation of the improper integral from 0 to 1 of natural log of x dx. It is equal to the limit as t approaches 0 from the right of the integral from t to 1 natural log of x dx, which is limit as t approaches 0 from the right of x ln x minus x evaluated from t up to 1. And so now we can plug in 1 for x first. So this is equal to limit as t, we haven't taken the limit, so you have to limit t approaches 0 from the right. Plug in 1 for x, so it's 1 times natural log of 1 minus 1, and then minus, plug in t for x, so this is t, quantity t, natural log of t minus t. And so natural log of 1 obviously is 0. This is equal to the limit as t approaches 0 from the right of minus 1 minus t, natural log of t, plus t. As t approaches 0, t goes to 0, and minus 1 is unaffected. So all we have left is this limit t ln of t, which we don't know what that equals to at first because it's an indeterminate form. Limit t approaches 0 from the right of t natural log of t. So the t in front of the log goes to 0. ln of t as t goes to 0 from the right approaches negative infinity. We have this indeterminate form 0 times negative infinity. To use L'Hopital's rule, we must first take the t in front of the log and put it in the denominator as 1 over t. Now the numerator approaches negative infinity, and 1 over t goes to infinity as t approaches 0 from the right. That's an indeterminate form that allows us to use L'Hopital's rule. And then we have the limit as t approaches 0 from the right of the derivative of the numerator, which is 1 over t, over the derivative of the denominator, which is negative 1 over t squared. This simplifies to limit t approaches 0 from the right of negative t, which goes to 0. So now we have everything completed, and we can now state clearly that the integral from 0 to 1 ln of x dx equals to minus 1. That is, improper integral from 0 to 1 of natural log of x dx converges to minus 1. And that area that I drew earlier, since the area is below the x-axis, we should get a negative answer. The total area enclosed is 1 square unit. The minus represents the fact that the area is below, the region is below the x-axis.